we're stopped and we're back going again. So Lavender, are you here? Talia?
I'm here.
Can you able to present? Or are we, or is there a, there you go. Looks like you're coming up now. Now let's make sure I have the recording set to record you. All right. Is there some issue with everybody's network today, or is it just mine?
Mine at
I've
least has
also,
definitely been glitching.
it's been very intermittent for me.
All right, we'll see how this works because I have one monitor and many windows. Oh gosh, that's no, that's not it. How to do this properly? Is there a way to just share one window of a browser?
There should be, yeah.
No, it's for some reason it's showing both windows when I do that, which is incredibly annoying.
When you were just sharing just now, I was only seeing the one window. The other one was grayed out, I think.
Yeah.
Dang.
Actually, if you want to do a next kind of thing, I can. I'm going to put away the. I can present for you.
Yeah, it just gives me an option to share the entire application. It doesn't give me an option to just share a tab. Ooh, interesting. Very
Okay.
interesting.
So
Just drag the tab into a new window.
Yeah, it goes by windows, not by tabs, because tabs is like a sub-level thing. It's not recognized by the desktop environment.
This is I think it's working. Is it working?
We're seeing Lavender 3.0, Talia Nero, and then we're seeing speaker notes and audience.
That's annoying. Yeah, that's what I thought it was going to be.
okay, here I have I can take over the stage. Let's use my window, and you just tell me when to click.
All right. Yeah, that's probably how we're going to do it. WebEx is so annoying, and the monitors are too small. I can see why people like to use multiple monitors now. All right, so let's get started, finally. Let's see, my video is off, microphone is on, presentation is on the thing, and this is Lavender. Well, this is Lavender's presentation. I'm Talia, and I'll be presenting the progress on the third iteration of Lavender for this spring 2021 semester. So, next slide, please. As you can see, we had a lot of people working on the project this semester. Almost as many as last semester is good. I'm Talia, and yeah. So, just an overview of the project structure. A lot of this was covered last semester, but for those of you who weren't there before, or if you want to hear, or if you need to hear it again, this Lavender is written in Rust using the cargo package manager. Everything's unit tested, which makes finding bugs a lot easier than it would have otherwise. Updates from last semester. Now there is a type section of the AST. There are type visitors and symbol lookup, which will be described on the next slide. Yeah, yes, lots of collaboration going on between me and myself. So, new progress this semester, hierarchical symbol lookup, which basically for the lay programmer means when you make a variable, how the interpreter knows which variable it is, even if they have the same names. So the old implementation used to have all of the variables inside of a hash map. That was just a flat hash map that just had the full name of every single variable in there. And there wasn't any ordering or any sorting of anything. But the new implementation stores the symbols in a tree based on the location of the variable. And so it's a lot easier to query all of the variables in a scope, which will be useful later on in extracting types. And it also has the side effect of assigning all the symbols indexes, which means that I can remove lifetimes annotations from a bunch of things and generally decouple different modules of the code so that the unit tests don't have to construct a bunch of supporting infrastructure just to test one piece of code. And the second thing that happened this semester were the type visitors. All of the Lavender version 3 is different from Lavender version 1 and 2 in that it is statically typed, and so all of the types have to be inferred and checked. So these type visitors will basically walk over the AST and extract types and try to infer them, right? For those of you who know what type inference is, you'll know what instantiation and unification are, but for those who don't know, instantiation is basically generating a type from like generics, and unification is basically type checking. So those are done, but not tested yet, and they're not yet integrated with the rest of the project. And next. So, what did we accomplish this semester? We accomplished some things on the path to implementing type inference, but we're not there yet. The code is a little less coupled, less lifetime annotations. But there is still a lot more to do. The type system has to be integrated with the rest of the code, and especially the symbol lookup and the backend code generation still has to be done. So I believe that is all for slides. So are there any questions?
So we have a minute or two here. So here's a. So you've been working on this largely by yourself, right?
Yeah.
So what exactly are you trying to, what's your ultimate goal of this project? I mean, what are you what beyond current languages are you trying to actually achieve?
Well, I'm trying to make a pure functional programming language that doesn't use garbage collection. So unlike Haskell, which does.
Oh, cool.
Yeah, basically that doesn't use garbage collection and that doesn't have a lot, and that cleans up a lot of the warts of other older functional programming languages.
So a functional programming language with lots of bells and whistles that doesn't use garbage collection.
Basically, I'm trying to minimize on the bells and whistles too, because the more bells and whistles, that means the interpreter is more complicated.
Yep.
The interpreter to be complicated. Not me. Only as complicated as necessary.
Nice. Do we have any other questions for Talia?
Sure. How are you planning on handling side effect propagation? Just standard monad-based approach, or something more complex that can also handle variable side effects? I think we've talked about this with affine types and stuff, but want to hear what you end up with.
Yeah. So lavender has never had impure effects in the past, mainly because I hadn't gotten around to implementing them yet. It's still a bit of an open question how we're going to model IO and other impure effects. I'm gonna interpret your question as meaning how to model like Haskell's IO monad, the stuff outside of the interpreter interacting. Right now, it's still a bit of an open question, but I'm leaning towards something like Haskell's monadic IO, but because the way to work with effects, since impurity is basically an effect, and effects are monads, it would be a bit difficult to see it as an effect without naturally having a monad instance for it. Does that answer your question? Kind of orthogonally to that, I'm looking at doing some kind of affine types as well, perhaps in the future, to minimize the cloning that happens in the background. Because no garbage collection, lots of cloning.
TutorBase, while we're going through this, let's get TutorBase up here and start sharing.
Any other questions?
Yep, I can share my screen.
Okay. Any more questions for Talia while we're getting this going? Let's see.
You appreciate the sheer number of people working on the project this semester.
Yeah. Well, thank you for your presentation. Nicely done.
Looks like I see a question here. Does Lavender use JIT recompilations? Lavender's interpreted, so I depends on what JIT compilation in an interpreted language.
My take on that question is they're asking if it, as part of the interpretation process, gets compiled to a bytecode like just in time, or gets compiled to assembly code as it's being parsed or something.
Lavender right now has an AST representation and a bytecode representation. The bytecode representation is what will actually be run in the interpreter, while the AST representation is what is going to be used for semantic analysis, stuff like type checking, symbol resolution, and optimizations.
All right, I'm gonna have to cut it off here. We do need to get we do need to move on. Thank you, Talia. Very nicely done. TutorBase.
All right, cool. Yeah, so we're TutorBase. We've been here for a couple of semesters, and yeah. So what is TutorBase? Yeah, so it's basically we're connecting people who want tutors with tutors. So clients can search by class and subject. There's a simple scheduling process, and really cool. This semester we added some new email and SMS notifications, which are cool. And we use the MERN stack. So this is our team. It's a little smaller this semester, and our two project managers are actually on their away semester for Arch. So that did change how we operated this semester a little bit.
All right, so coming from that, we're going to go into our project organization. So the way we organized our project is we had each of our tasks kind of on 2-week sprints that we tried to follow as closely as we could. Of course, going a little over, a little under, depending on how intense the task is. Also making sure that we have our bi-weekly meetings after each RCOS meet. Along with those 2-week sprints, every 2 weeks we would meet with our project leads who are on our co-ops, make sure that we're kind of like all staying together. Throughout the semester, we were also using a Jira board to manage all of our tasks, and along with that, we were also using GitHub issues. All right, so this is kind of the timeline of our project. So we started off our first sprint trying to work with finishing up scheduling meetings and authentication. We ended up running into a bunch of issues that we've kind of had to make a decision on. Do we want to try and fix the issues but have it not working as great, or should we try something new that we know will work even better? So that kind of led into a major refactoring of our entire project where we practically redid our whole back end, which kind of led to some more, which led to significant front end and UI modifications. And now we're kind of just trying to work on finishing our refactoring, adding in some of the finishing tasks, and hopefully looking into some sort of deployment very soon. And here's an example of our Jira board. Each task, labeled as in progress, pending view, and complete. And now we're going to talk about the implementation accomplishments over the past semester. So I'm Jacob. And this is kind of what I've worked on. Myself, along with Nick, kind of stepped in as intermittent project manager with Jeremy and Jason on co-op. And as for the project itself, I worked on a lot of the front and back end refactoring, adding in additional routes, modifying appointment schema, and adding in different schema, and then making sure that all of the new refactored routes were added or modified in our front end, along with modifying and fixing our scheduling process, both before and after the major refactor, and modifying our meetings display page after the refactor.
Yeah, so I'm Nick. I also stepped in as a project lead, and I worked on the backend refactor, which was defining the routes a little bit better and adding some new routes. I also created an Insomnia template. So Insomnia is a REST client, so you can do REST calls. And what's really cool with it is you can set up all your API calls and then you can export it. And I added that to our Discord, and I plan on adding that to the repository so anybody can pick it up and import it, and you'll be good to go on your API calls. I also did the front end refactor, and a lot of that was converting JavaScript to TypeScript. So TypeScript is just JavaScript with types. It makes debugging and making new code easier. We also converted from class components to functional components in React. That allows us to use hooks. And hooks are also very fun to use, makes things a lot easier. And I also updated the scheduler. Some pictures on the side. I added some environment files. You can see all the TypeScript endings, TSX. And then on the very far right, you can see a picture of the Insomnia file.
Hi, I'm Sunny. So mainly what I've been doing is working on the authentication. We had problems since the end of last semester. But yeah, so we found a solution for that where we can send tokens at once getting authenticated by CAS. So yeah, so I worked on the token management and the token storage, and then I started working on route blocking, which I did route blocking on both the front end and the back end. And then there were a few bugs in the front end which I ended up fixing while I was doing that. And then I also did documentation throughout since we refactored the routes. So some of her documentation kind of went away, so we kind of I had to go back and redo it. So yeah.
Hi, I'm Thomas, and I contributed to TutorBase largely through front-end development. And on the front end, I made several key contributions, most notably to our login page and sign-up page. And both are redesigned this semester to give it a cleaner look, and most importantly, to be mobile-friendly on any viewport. I also made several front-end changes on scheduling the times for tutors, which includes the date-time preview. And on the back end, I contributed API calls to the tutor scheduler that adds the newly selected time to the tutor's portfolio. And also, I made some wiki contributions to reflect some of our changes, development, and refactors.
Hi, I'm Chris, and so my work on TutorBase for the front end this semester was I worked with Tom to help make the sign up and login pages more mobile friendly. And then on the back end, I fix various bugs and logging issues. And I also created an appointment confirmation endpoint on the API. But the bulk of the work that I did this semester was on creating a notification system. So for signups and appointment confirmations, we now are sending emails and texts to users through the open source Node emailer package, which sends it directly from the backend, when previously we were trying to send emails through an external API, which had some pricing issues and it was also not open source. And I also added SMS notifications.
Yeah, so now we're going to show everybody some screenshots of what we made. This is the cool login page that Thomas made, nice and clean. And when you click the login button, it redirects you to CAS, where you can log in. Go to the next one. This is the scheduler. This is actually kind of outdated, but we updated a little bit, and the tutor times are now blocked off on the scheduler. So if a tutor already has a schedule during that time, you'll see a blocked off calendar event, so you can't make a time during that. Go to the next one. This is probably the coolest part of the project this semester, Chris's notification system. So as you can see here, when you sign up or when you create an appointment, you'll get a notification via email or SMS, depending if you put your phone in there. Also, if you're a tutor, if someone makes an appointment with you, you'll also get a notification, which is really cool. And this slide is just a overview of how the appointments look in the app. Go to the next one. And this is just a tutor profile. So this gives an overview of a tutor and what, shows their availability, their pricing, and the courses offered.
Okay, so this is kind of like looking more in the future of TutorBase into next semester and the next academic year. We're really hoping to finally deploy the project. We were really set back with a lot of the major refactoring and errors this past semester, and hopefully having Jeremy and Jason back as our main visionaries will kind of lead more in that direction. And this semester was also kind of off because we had lost a lot of our contributors. So hopefully looking for more people to jump on and getting some more user feedback once right before deployment. Sorry, the wrong direction. And some more longer term goals is RPI adoption. Having this be like a standard RPI use. We even had a conversation with ALAC as a possible joint implementation, which would be really great. Of course, a mobile app to make it more easier, and payment handling, doing payment processing right through the platform. Just again making it much more easier, much more structured. And yeah, that's sums up TutorBase and our semester progress.
Yeah, this semester was really the refactoring, I think, made our code a lot more maintainable. So going further into the future, it'll be a lot easier to change or add things. And that's it. Any questions?
All right, I think maybe we'll type some questions into the chat if there are any. Otherwise, let's We're trying to make up a little bit of time right now. So let's get our next competitor started up here. Let's see. Who is that? Would be off campus. So if off campus is ready to get started.
Yeah, I'm sharing my screen right now.
You are
Wait a second.
All right. Yeah, I see it coming up now. Excellent. So TutorBase, while we're waiting for this to come up all the way.
Hold on. Sorry, give me a second.
Sure. How close are you to a minimum viable product? Are you about? I kind of missed that part. Are you about at that point, or?
Yeah, we
Yeah, we-
are.
oh.
Sorry, Nick, you can go ahead.
Yeah, we're there. All we have to do is set up deployment. This semester we were adding. It was supposed to be the finishing semester. We just wanted to add a few more little features, and then we were going to push forward.
Cool.
But we decided to do a refactor to make our code a lot more maintainable. So hopefully next semester we can set up deployment and then be done.
It's never done. Then
Yeah, it's
complaints.
true. Absolutely.
All right. I guess thank you. I wish we had more time for questions. I don't want to take up too many classes with this because I like you guys to have time to work. But that moves us to off campus. Are you ready?
Yeah, I'm ready.
Go ahead,
All
knock
right.
yourself out.
Got you. All right, so we are off campus. Currently this semester we have me, Abdul Muiz Youssef, Josh Malek, and David Mata working on this project. Everybody else on this list were contributors last semester, but they're currently working full time right now. So I kept their name up here because they're still on the project, but they're just pretty busy right now.
Yeah, so the purpose of off campus is we felt like there was a need for kind of a centralized platform for housing in Troy, but we wanted it to be student centered. We've all used Places for Campus or Reddit or that kind of stuff to find places off campus if you're an upperclassman, and it's always kind of a headache to find the place that you actually want. So we really wanted to help students in their search, and also we wanted to allow a place where students had some kind of, or landlords rather, had some kind of accountability with students, and students could keep track of who the good landlords are in Troy. Yeah, next slide. So as part of our work in off campus, we built this big web application. With our platform, students can post and view reviews for landlords as well as property reviews. So you can actually look at the different houses around Troy, and also you can see the ratings for the house and you can see the ratings for the landlord separately. So you can see, the house is pretty nice, but the landlord sucks, or vice versa. Pretty much the purpose of this was just to give students more control and also to help landlords have a little bit of an easier time, because a lot of the landlords in Troy are not as technology friendly. So we wanted to help with that too.
All right. And with that, I'll go in and show some of the views that we have. So here we have the landing page. I try to capture like a animated GIF of it, but it's a little too slow. The GIF itself is slow. You'll see it come up now, but we got some animations going on to kind of like draw the viewer in or whatever. And we went in and did a UI overhaul. This is our old the old UI layout and design. This is for the search page for the properties. There's a bunch of placeholders, and this is the new one. We changed up the theme and the colors and everything, so now it looks a little bit more modern and sleek. And we're currently working on the mobile app for the students. So that's what we're spending most of our development time on right now. So we want the students to be able to access the application from their mobile device. Our old plan was to have a progressive web app to be able to download the application straight from like Chrome. But currently, progressive web apps are still like kind of in their infancy, and also Firefox. Am I muted? Hold on.
No, you're good.
Okay, okay. I thought I muted myself. My bad. All right. Sorry. Yeah. Well, Firefox made an announcement saying they don't have future plans for developing or bringing progressive web apps to their platform. So even though like Chrome is like the big player in the browser market, we wanted to provide accessibility for anybody with a mobile device. So the better choice for that would we decided to just make a cross-platform mobile application using Flutter. So our development stack on our backend, we have a Node JavaScript with an Express server. We're using the Merge stack, so MongoDB. Our API is being served through GraphQL, and on the front end, we have a React with state management through Redux, and then now we also have Flutter for the mobile application. And so my contributions, I basically worked on I worked on, I guess, full stack because I was working on the front end and back end, working on the designs. I had to mock up each view and then implement it through React. Also worked on the APIs needed to serve the resources for the application to work, all in Node, JavaScript, GraphQL, and through Express, and also implemented testings so that we can have some stability in our project.
Yeah, I'll talk a little bit about what I did. I worked mostly in the backend and mobile app builds. In the backend, I worked on our GraphQL routes and building documentation for that, as well as basic server stability and that kind of stuff. For our mobile app, that's what I've been focused on for most of the semester. We basically started from just a scratch Flutter app and built up all the screens and routes and everything we needed, state management systems, NoSQL databases and everything like that for user data through our queries, just to reduce overhead when we're trying to actually do queries on the mobile app. We want to make it as efficient as possible. Yeah, and the other big thing I worked on was a property image retrieval. So whenever a landlord adds their property to the service, we want to make it as easy as possible for them to just actually get us started as easily as possible, pretty much. So they'll put in their address that they own, and after we review their lease information and verify that they actually own the place, they can set up amenities, and we'll actually pull down photos automatically from Google Street View, just so they have something, a placeholder, and they can also add their own images if they choose to. And yeah, that's what I worked on.
And David Mata worked on basically writing documentations for our backend and helping with project organization, which is pretty important in the project. So the project organization, we're using GitHub with issue tracker and for project sharing also, and for delegating tasks, we're using Trello also to keep track of current goals and general project management. Our repository has 799 commits, 80 pull requests, 75 issues. So it's distributed among various repositories, since we needed to have separate repos for the backend and front end, and also for the mobile app. So we have three separate repositories for those. And we competed in the eShip2 competition, and we were able to win second place for our project.
Yeah, so looking to the future, we currently have been contacting landlords to be part of our beta. We have about 30 landlords so far. We're getting more. The more landlords that join, the more landlords want to be part of it. So it's kind of a snowball effect. Right now, we're planning on having the beta be open by midsummer. We push it back just a little bit to allow a little more flexibility in having people, landlords specifically, join the platform. And then we're going to actually start working on writing tutorials, because, as we said, a lot of the landlords in Troy aren't as technology friendly or as cohesive or as good with technology. So we want to build easy tutorials and get them as easily into our platform as possible, and just kind of bring them into the modern era with that kind of stuff.
Yeah, and on top of that, speaking on the landlords, I'd assume most of them are like in their maybe mid-40s. I don't know, any like 30, 20-year-old landlords around here. So like things like using Internet Explorer are definitely out of the question, because I'm 100% sure it's not Internet Explorer friendly, and we don't intend to make it. We need to move on to the future. And also, we planned the beta to be midsummer because we wanted to kind of line it up with, I guess, the intentions of the students. We'd assume that students will start looking for fall housing sometime like midsummer, or maybe even early summer or whatever. So our plan initially was to have it sometime in May, but that would be a little too early, and we also need some time to finish up a few more tasks before we start our beta. And that is our presentation. Yo.
Are you there, Professor?
I was just talking over and over and
I-
over again. Yeah, anybody from adversarial robustness toolbox? Let's let Abdul
Hello?
cede the stage. Hi.
Yeah, we're here.
All right. So I actually wasted the question time talking to a muted mic. So we'll catch you guys up. Nice job.
Thank you.
Sorry about that. Maybe I'll just leave my mic on. You guys don't. If you hear my typing too loudly, then please let me know.
Okay. Hi, we're at Adversarial Robustness Toolbox. The team consisted of myself, Jeffrey Fang, Nicholas Kwok, Sean Hung, Gabe Orlansky, and Biat Buzer. So we used a waterfall methodology to work on our project since we felt our group was really small and the workflow just seemed to work well since we had to do a lot of research before we could actually start coding. So what is art? So machine learning can be attacked in four ways: evasion, poisoning, extraction, or inference. So art is a Python library for machine learning security designed to prevent these attacks, and it supports all the frameworks. Some of them that you might have heard of are TensorFlow, Keras, PyTorch, or Scikit-learn. And we also supports all data types, so videos, text, or images.
So I'll talk about our organization of the project. Our project implement the over-the-air flickering attacks against video recognition network is an issue 881 under the main branch. So to implement, we forked the repo under the Gabe's repository. We had created 3 branches in the repository to help us organize our project. So before we start working on this project, we need to understand what things or tools should be used in this project. So for the old over-the-air branch, we mainly use issue to assign different parts of the research paper that need to be researched on. For example, understanding the actions, Google's media pipe preprocessing tool, I3 model, and Kinetics 300 as our sample data set. After researching, we create a create over-the-air branch to start implementing the function and the model in our project. And the last branch we create is unit test staff branch. It is a quality assurance branch that makes the unit test for the code function that has been implemented in current over-the-air. And for that, we also create the art over-the-air research documentation to help next semester student or developer who want to continue to develop it. The documentation includes the datasets, file formats, and all the blockers we face and how we solve them.
In the over-the-air paper that describes the adversarial attack on a video recognition model, they used a video recognition model called i3D. However, we were unable to use that model due to an incompatibility with Python versions. Instead, we used a model called MMAction. MediaPipe was also incompatible with our project because it only supported C++, whereas we were using Python. However, after discussing with Dr. Buser, we decided to skip pre-processing the videos with MediaPipe. For the dataset, we used Kinetics 400, which is a collection of links of video clips that cover 400 human action classes. This is stuff like extinguishing fire, bartending, or juggling balls. For our project, we randomly sampled a handful of videos from 10 different classes that we chose, and we wrote code to download these videos to our video recognition model.
So to implement our attack, we use PyTorch and MMAction 2 with Google Colab. And basically the attack is that you want to add a very slight perturbation to every single frame that slightly changes the color channels in such a way that it would be unnoticeable to us, but it has an effect on the classification. So in the bottom right, you'll see a very brief image that is a quick demo of what the different filters would look like on a kid juggling balls. So obviously to implement this, we would need a machine learning framework, and that's why we chose PyTorch, because it's very popular and Art has native support for it. And so we were able to fool the very simple model on a demo data set, and that's in the demo, but unfortunately it would take too long to run now. So if you would like, you can just go to click it and see it. But what we have remaining is we have to fully implement it inside of Art so that other people can use it, and we need to finish up the unit test as well.
All right. So you guys, is this, I guess one of the questions that I had going forward on this is, are you trying to fool somebody else's machine, or are you trying to make your AI robust to these types of attacks? Is this a testing system so that you can improve your own, or an attack system so you can break somebody else's? If that makes sense.
Yeah. I think the overall goal is to have it so that people can improve their own models and help defend their own models. Now, obviously, you could like use it to attack other people's models, but I don't think that's the motivation behind creating this project originally. So it's overall more for making your own models more robust to these exact attacks.
Cool. So you were one of the IBM projects, correct?
Yeah.
Yes.
Nice. Good progress. That looks like a lot of fun. I am hunting around, and thank you for being both interesting and concise. Good job. I think the next one is what are you calling it? Telescope or RCOS infrastructure?
RCOS infrastructure. Are we, can everyone see the slides yet?
It is currently still black for me, but, well, it's actually like a dark charcoal gray. But let's give it a few minutes and we'll see what comes up. A few seconds, hopefully.
Come on, WebEx. You can do it. We believe.
Do we?
I don't believe in WebEx personally. I don't. Oof.
Well, we know it exists, but perhaps we don't have faith. Is it better?
Yeah.
Perhaps try redoing it. So sometimes.
Yeah, I'll see if I can. How about now?
Still says starting to share.
Do you want to give it a shot, Frank?
Sure.
Yeah,
Hooray!
this is showing.
There we go.
This is a weird
Perfect.
interface. Okay, just next slide and I'll go.
All right. Hi everyone. This is the RCOS infrastructure team or RCOS infra team. I'm Nia, and I'm doing this presentation with Frank and Steven. And let's get started. So the team is us three coordinators. I'm Nia, as you all know. I'm the Telescope project manager. I do development across it, front end, back end, and I also do development and maintenance on the database and API. This is my 7th semester in RCOS, my 1st semester coordinating, and my 6th semester mentoring. My email and Discord handle are all down there, so if you need to reach out for me about this presentation or about anything else RCOS related in general, go for it. Next we have Frank.
Hey everyone, I am Frank, the full stack dev, the database designer, the handbook reviver, the bot designer, the too much time spent doing RCOS, or as I'm sure everyone knows by now. And here we have a nice picture of me. You could tell it was not taken in Troy because I'm smiling and I'm tan. This is my 6th semester in RCOS, I think. My 5th semester coordinating, I think. 4th, or I have had 4 semesters as a project manager and about 4 mentoring as well. And the fact that I can't remember all those accurately makes me feel a little old. You can find me on Discord or at my RPI email.
All right, I'm Steven. That photo was taken an hour ago because I didn't have a good photo. So I'm full stack because the only way to do a project with 3 people is everyone does everything. I'm the main sysadmin. I run all the servers, do all the Docker things, run evil SSH commands, and I mostly do it all through Emacs. I've done RCOS for 8 semesters straight. I remember joining on my 2nd day at RPI. This is my 5th, I think, semester coordinating. I think I joined halfway through 1 semester, so somewhere I lost count in there. 7-ish semesters mentoring, I think. And I've started at least 6 RCOS projects in that time. There's my RPA email and my Discord. So it occurs to me, I'm only going to have that email for another couple months. So I put my regular email in the chat in case you need to talk to me once I'm gone.
And by gone, we mean graduated, of course, not.
No, my email works across dimensions, don't you know?
Yeah. All right, so we had a 3-pronged approach. We had Telescope, which is live at telescope.arcos.io, and you can find our source code at the repo, also linked here. And then Telescope acted as a front end for all of the user and meeting and semester data, which was stored on the RCOS database, which is the source code, and the migrations are all linked there too. And then we had it documented, or we had documentation posted on the handbook, which is at handbook.arcos.io, and all of the markdown is on that repo. All of the infrastructure projects are licensed under an MIT license, and they're all maintained, at least this semester, but also in previous semesters, generally have been maintained by a group of RCOS coordinators. The public-facing projects we make an effort to make them accessible and easy to report bugs or modify to the general public, so they all have issue templates. And I believe the handbook also has pull request templates, which is really cool. All repositories, of course, have READMEs documenting how to build and contribute and install them. So we try to put thought into making these accessible, especially not only to future coordinators, but to the general public. So let's start with Frank on the RCOS database and API.
Okay, this is a fun one. The motivation here is, well, there's a lot of motivation. I spent a lot of the summer thinking about what could be done once RCOS started this year, and I realized that RCOS data is spread over so many different platforms and services, as we all are very familiar with, and as we're also very familiar with sometimes, that doesn't work out very well for members. So imagine how little it works out for us coordinators and faculty advisors. The RCOS database, in response, is an attempt to unify all RCOS data, past, present, and future, all in one place. It's a pretty big goal. And the highest priority of this, of course, is longevity. As you may know, Telescope is not the first observatory page. I guess we shouldn't say it. It's not the first RCOS management page. We're hoping it is the last. As coordinators have come and gone, we've scrapped and refreshed different infrastructure things, and they all had different databases and things assigned to them. So our priority here with the RCOS database is longevity. This is going to hold all previous data, present data, future data. So any front-end stuff is really just going to be an interesting and useful interface on top of this data. So yes, as the pressure is on Telescope. And I had a workshop on this earlier in the semester, so if you want to see details on that, check out these two links. So first we have the original design, which pretty up to date. It's crazy, it looks pretty cool. Definitely check that out. And then we have my slides for the actual database workshop. In terms of technologies, it is a Postgres database. We currently have it managed by DigitalOcean, makes it more maintainable for us. And to actually connect with services, we use an RCOS API. We use a GraphQL API, currently handled by Hasura, which is really cool. Just kind of plug in the Postgres database, it handles the rest. Previously, we used a REST application that kind of just provided an automatic API as well. So this is also pretty maintainable for us as well.
So all of our different aspects of the infrastructure, both the old infrastructure, which is the quote unquote current RCOS.io, and the new infrastructure we have been working on are hosted on DigitalOcean. The old infrastructure is kind of alone in its own droplet that Professor Turner pays for, and everything in the new infrastructure is all on one Debian droplet that is running Docker. Everything is orchestrated by a single compose file, gets launched nicely, secrets are managed, and all public-facing HTTP services are proxied with Caddy for automatic TLS, so HTTPS. Just kind of a lone whale in the DigitalOcean.
And for the handbook, we have, this has been long lasting. It's not a new idea. It's been around for a while, a couple of years, but it was kind of, it had fallen out of use. It's been revived and working on it, though we are working to move it. For now, it's in this repository that Steve will show in just a second. Go ahead, Steve.
So in the future, we hope to migrate the handbook to the new RCOS Wiki, which is currently up and available for contributions at wiki.rcos.io. Be great if we got that going and people start using it more, because there are a lot of things, old presentations, workshops, things like that, that'd be really nice to have written down and available all in one place.
And then the last and largest prong of our infrastructure approach is Telescope. Telescope is the next RCOS management front end. It currently serves a website that's live at the URL that is previous and in one of the future slides. But it will also soon have a Discord bot front end, and since the RCOS database and API doesn't manage any authentication stuff, Telescope is responsible for authenticating with GitHub, Discord, RPI casts, and other services. It's on its third semester of development. At the beginning of this semester, the structure of the project had to be changed significantly to use the RCOS API rather than the previous internal Postgres database that everything was, using directly. This gutted the backend and the authentication system, which was previously self-managed and is now moving to OAuth. But despite this, massive refactor at the beginning of the semester, I feel that Telescope has made pretty significant progress. Here's our commit graph here. And now I'll talk about some of the features we added. So new features, obviously, new authentication system. So we have GitHub, Discord, and RPI Cast all available for account creation and sign-in. And then sometime soon, I'm going to be able to add them as neither account creation nor sign-in, just to link to an existing account, which will be very cool. And then we also have the meeting page, which is actually in use if you click any of the links in the meetings in the slideshows for the large group meetings. It hosts a list of all of the meetings in the database, and that's what I'm currently working on. We're adding forms to create meetings, edit meetings, delete meetings. So that's a big, nice new feature. Telescope's written entirely in Rust using the Actix web framework. We also use handlebars as a templating engine, and for the HTML and other front end stuff, we have Bootstrap and jQuery. Feedback wise, we have Telescope Live. I've done a few deployments this semester. Our main way of getting feedback so far has actually been the testers channel on Discord. I watch there pretty closely for feedback. And if you want to try out Telescope, or if you have issues or whatever else you want, go there and I'll definitely see it. You can also make an issue on the repo, which is linked here. I watch that pretty closely as well. The future for Telescope and the rest of the infrastructure is hopefully long. I plan to continue working on and deploying new versions and features for Telescope throughout the summer and fall semesters, as long as I'm here, basically. Hopefully, we'll be replacing Venue and Submittee separately for status updates and attendance over the next few months. The database, API, and handbook are all, at this point, relatively stable. Our plans are to solidify them as part of RCOS so that they're not forgotten or lost after, Stephen and Frank and I all graduate. And so our main goal with those three is to document that they exist, add them, link them all to each other into Telescope, and if the wiki gets off the ground, add them to that too. Thank you for your time. Is there any questions, comments, or anything else?
All right. While we're typing questions up, let's see if we can get OED ready to launch. OED, are you out there? Ah, there we go. Luke Levin is. All right. And any. I don't know. You guys have a lot to compete with. You're getting cocky already. All right. Please type any questions to our presenters into the window. Don't let them monopolize the chat there. And in the meantime, let's get started with the Open Energy Dashboard.
All right. Hello, everyone. My name is Lewis. I'll be introducing OED. OED stands for Open Energy Dashboard, and this semester it was one of RCOS's external projects. Our project lead is Steve, who is here with us today. So you'll hear more from him at the end. And we had 4 members, me, Hannah, Luke, and Miriam. So with that out of the way, I'll pass it to Luke, who will talk more about OED.
If I can figure out this UI. Okay. So OED is Open Energy Dashboard. It's essentially just a collection place for lots of data. If you know anything about how electricity is delivered to buildings, there should be a little meter next to it, and that meter just records how much electricity you're using. So the goal of this program and similar programs is to have all this data in a nice place where we can view it, have it look pretty, see where it goes up, see where it goes down. And the ultimate goal is we should see where it goes up and try to get it down in the future. Just go to the next slide.
The way OED works is that it collects energy data from its clients, which might be individual institutions like universities like RPI or campuses of collected buildings. And then it collects that data as meters and then processes that data and displays it however the user would like. So there's a lot of flexibility. You can decide to display it as a bar graph or as a map or a line graph. And you can see on the left in the picture there, you can select certain meters that you would like to show, certain groups. And then on the right there, there are other login and preference features, just like quality of life things for administrators. You can select your the language that you would like or the time zone that you are in. Next slide. For the project organization, OED is an external project, and it's organized with many developers across a couple different universities. So we were not directly in contact with them unless we were just working with them and needed something for them. But we are each individually managed by the full-time project lead, who is Steve. And there's a dedicated development documentation site for the project, which is very robust and very thorough. So if you're a student who would like to do OED, it's really easy to get started. Progress updates? Okay, I'll go first. So I added a couple small features. I added a version number to the footer of the site. So the client knows what version of OED they're on. This ended up requiring a lot of learning React and about the React Redux store, which is a feature of React. And I also added a drop-down menu where users who are not admins can select their preferred language for the site. I added a really simple fix to make sure that non-exportable maps do not have an export map button, because you can't do that. The issue I'm working on right now is fixing a bug that creates a problem rendering data points on the endpoints of the x-axis of the dashboard graphs, which you'll see in the demo. And then I created a couple issues throughout the semester, mostly cosmetic. Over to you, Luke.
Okay, my turn. So this is actually my first semester during RCOS. So it was a little bit of a learning curve for the new technologies involved, mainly the Docker that we use for the different Dockerized containers, Postgres for our database, and then different languages like TypeScript for the actual web pages themselves. So my first PR was actually for the developer website that Hannah mentioned earlier, just documenting what I had to do to get it working on my machine. And then as the semester went on, I worked on the project itself. I spent a long time doing internationalization. There was a couple issues where certain parts of the site weren't properly using the right language, namely the plotly graph that we'll see a lot more of later, and the different moments that we use to record time. So just trying to get them to use the right language that's selected in the user preferences spot that Anna mentioned earlier. And then after that, I spent a little work modifying a web page that I'll go over on the demo later. That basically is a list of all the meters. And that involved a lot of working with Redux and React as it works in conjunction, and TypeScript eventually. So a lot of new stuff I've never really seen before. It was really cool to hop into it with something real and get a good feel for it.
Okay, so I worked on 3 main issues this semester. The first one was additional tooltips, which are the little widgets that you see on the side. Essentially, users can hover over them and it'll display text about different components that OED has. And if you look, there's a link at the end, which will lead you to a help page if people need more information. And they differ a little bit if you're an admin versus if a user. If you're an admin, it takes you to the admin help page, which just has a little bit more information than regular users have accessible to them. I also added a drop-down menu. Originally, OED had a group of buttons to switch between the different graph types. But as we add more features, it's sort of getting cluttered. So we want to make sure that we can get that in a new format and avoid, having to add more space or something like that. And then the bulk of my semester was spent working on a revamp of the pipeline system behind OED. So this system is really how OED processes meter and reader values. So we get CSV files, and these files can come in different formats, and some of them have more parameters than others, some of them have less. And depending on those parameters that are passed in, we have to process it differently. And there's a whole design choice that was spent, documents and all this that I read and spoke with Steve about and learned a lot about OED in order to be able to do this. And it was really cool for me because last semester I actually had comp org and I worked on, a pipeline design. So this was very familiar to me in that sense. With that, I think I'll pass it to Luke, who will be doing the demo.
All right. So essentially, I have a.
Oh, we can't see it, Luke.
Hold on. Let's see if I can figure this out. Nope. There we go. Okay. So you can see this now, correct?
Yeah, we're good. Thanks.
Perfect. Okay. So I have a local copy, I guess, of the website running on my local machine. So I guess I'll just show you some of the bells and whistles that we have. So this is the main screen. This is the Plotly graph I mentioned before. And what you're expected to do here is add meters. And as you add meters, the data gets loaded from them over however much data you have. So this looks like it's over a couple of years. And if we wanted to zoom in on something, let's say this dip in March of 2019, we just drag over this tiny little period, and then we redraw it to collect more data from the database. And we can see exactly what happened. Maybe there was an outage and we need to know when that was. We can add multiple meters to see how that data aligns with other places. So that's really the gist of this page here. See, I'm not logged in, so I can show you more pages if I am. There's an admin panel. This is where the preferences that Hannah mentioned before are located. I can change the default graph type. I showed you a line graph before, but if I were so inclined, I could show you that in bar graph over different time intervals. This is that meters page that I mentioned before. It's a table of all the different meters I have loaded in, all the different data. I don't want to get too bogged down with the details in the interest of time, but that's what this page is. There are also something called groups, which are essentially just multiple meters or multiple groups amalgamated together, so that if we wanted to show multiple meters and how they add up, we could also view that data readily and easily and zoom in as we wanted. And a very just quick, that took less than a click to zoom in on what I wanted to see. So it's all very at your fingertips is the intent. And then the last feature I'll show off is something relatively new, a new type of data that we've been experimenting with called maps, which are trying to put these meters onto physical representation so that we can see where energy usage comes from. So this example is a little bit big because we haven't normalized the size of these circles yet. But let's say this hypothetical place has a meter on the theater, and we can see relative to other buildings how much energy that's using compared to, let's say, Play Place, which has a much smaller circle. And yeah, that's essentially everything I have here, I think.
The fix for that is rolling out. It's much more usable now.
Yeah, I have. I'm pulled off of development, so I haven't gotten the latest commits for this yet. But
yeah,
I
and
think
we have just one last thing. Steve is
Absolutely.
here, and so we have a few future goals that the project is looking forward to with working with RCOS and stuff.
Yeah, hi. So with the help of RCOS students and other developers, a lot of important features have been added, and we're moving towards release 1.0 this year. And that'll take us from an electricity-based dashboard to one that can do natural gas and water, carbon dioxide, whatever units you want. And after that, we've had a whole bunch of interesting requests for business models using AI coupled with weather to make intelligent predictions about how much usage you might use at an institution. So we expect OED to be in active development for a number of years to come. So next slide.
That's all. Thanks for listening. We'll take questions in the chat.
Awesome. In fact, I'm typing one in right now.
So I'll answer one of them as the project lead. Why do we not do automatic redraws? It takes a reasonable amount of time to recalculate usage data. So our concern was as people drag the sliders on the bottom, we'd have to predict when they had stopped dragging them. Otherwise, we'd be constantly hitting the server to get more data. So in general, people don't do that as frequently. So we decided to make that a manual process. We could automate it, but it would require more resources on the server side, which some sites don't want to do.
Nice, thank you. Nicely done. So I want to install this. Actually, while we're talking, let's get the next group up, which is somebody else.
That's me.
All right. So if I wanted to install this on my house, is it ready for that yet, or is it still high maintenance? I mean,
Well, you need your own server, and it's a matter of how you would acquire the energy readings for your own home.
That was kind of my question. Is that part is there a way to do that from a consumer standpoint, or is it still at a higher granularity than that?
If you're one of the lucky ones that has a utility that allows you to access it, you're probably okay. If not, to give you an idea, it's in the $1,000 to $2,000 range to hook up an electrical meter that can be automatically read. So this is not something that your typical homeowner is going to do unless their utility has exposed their interface to you.
Yeah, I think I'm on National Grid. I expect that they don't share any more than they need to.
Yeah, so sorry.
No, but it's really cool. Thank you, Stephen, and all the OE.
Well, thank you to the team for doing this.
It was nice. Do we have somebody else coming on now, or?
Yeah, that's me. My bad. Can you hear me?
We can hear you. Oh, hi, Matt.
All right. Is it okay if you share your screen for my presentation? Just because my Mac, my horrible laptop, is screaming for air. So is that possible?
Is it posted someplace?
I'm about to put it in the chat.
Okay, yeah, I can grab it from there.
Everyone who presented today should also throw their slides up in the slide channel when they get the chance.
Is he sharing my presentation just because I can't see it? If he is, I'll just say next slide and I'll follow along myself.
I'm not presenting it yet because it hasn't shown up in the slides channel yet.
Oh, I put it in everyone. Hang on, let me put it. Oh,
just tell me where you put it. I can grab it from any.
The WebEx chat. The WebEx chat.
The WebEx chat. Ah, sorry. I was going through Discord trying to find it.
My bad then.
No, it's absolutely fine.
All right. So welcome to HF Test, everybody. This is my project. So first slide. Just gonna wait until we're ready there. Yeah. Could you go back one? Yeah. All right, we're good. All right. So just a quick preface for what HFT actually stands for. It stands for high frequency trading, which is a method of trading that uses very powerful code and machines to execute tons and tons of trades in roughly nanoseconds. And it's powered by quant researchers for basically the logic and very good software engineers for the actual build. So an example of a high frequency trading strategy is, you have currency arbitrage, you convert one currency into another maybe into another, and then into the original currency that you converted from. And then you end up with more money than you started with, which sounds impossible, but there are small little openings in like the foreign exchange market for that, which is very interesting, but they're only there for like fractions of seconds. So high frequency trading exploits that. And I thought it was cool. So I was like, dang, maybe I'll have an RCOS project on this. So next slide. So what is HF test? It's not important. That's what it's not. So no, I'm kidding. It's a tool that aims to aid the micro optimization of high frequency trading algorithms, specifically like the hot path code. So what it does is it utilizes binary instrumentation to basically hook into any code base and kind of measure how well the code performs, like the execution speed in response to certain market simulations. And we're able to actually give any binary these market simulations because of binary instrumentation, because we can override data and memory at runtime, so we can really do whatever we want with it. So basically what HF test brings to high frequency trading programs, algorithms, etc., is you can, like the binary instrumentation features are things like function hooking, so you can override any function with any parameters that you want. I developed specific financial data generators so that you can hook and inject those. And then you have things like call stack views, obviously, where, if you're hooking into a function, you're obviously going to see it occur. So you have a nice little stack of functions. And you can view, what exactly happened post execution, and then the desired analytics, because the way that this actually optimizes is through analytics. There's instruction count for given functions, things like the most expensive functions, whether that's like time or memory, like the frequency of the functions, and then frequency of data inside of it, like arguments, maybe just, so those are kind of the desired, analytics. And basically what HF test does, it optimizes through analytics, through showing you what exactly is going on. And it does that by providing insight through basically countless possibilities. So I'm like basically halfway done with all of these features. So that's basically overarching. So next slide. Yeah. So what it's not, and it never will be, like any kind of trading or investment strategy. Like I have no experience with trading at all. And that's not what this is. It's a software engineering project. I just thought that, program, do things fast. That's cool. So next slide. The timeline of development has been a little bit disappointing. So we started off with 2 developers. I spent a month and a half, maybe, teaching them low level and some market concepts. And then we finally begun development. And then they dropped the project because it was too much work. No shade at all to them. Those are my boys. Love them to death. But I had to continue development on my own. And I tried out a few instrumentation tools and different frameworks before finally arriving at my final tech stack. So here's some of the stacks that I ended up going with originally. So next slide. So I was originally going to use C++, Qt, gRPC, and Google Orbit. Google Orbit is a dynamic instrumentation-based debugger. So I basically created the skeleton of HF test in C++, and the goal was to use Google Orbit. We didn't actually end up doing that, unfortunately, because the user space instrumentation was just not there at the time, even though I thought it was. It was actually being actively worked on while I was pursuing this project. So didn't really match up in terms of time. If I want to rewrite it, maybe later, but not now. So next. Unfortunately, tried another few tools that didn't really work out too hot either. So, we tried Intel's Pin tool, which is another binary instrumentation tool. However, there were things that instrumenting user-defined types and injecting those and other stuff like that. I knew that was going to suck. so C++ is already a bit of a hassle to work with. Pin wasn't receiving the amount of love that it should have been for anyone to incorporate it on a big project that's supposed to instrument modern C++. So unfortunately, I wasted a couple of weeks between this and Orbit till I finally arrived at like not the holy grail, but what I'm using now, which is next slide. Python, Frida, which is you guessed it, binary instrumentation framework. Flask for like the UI, Pygol for like displaying things like charts, and then got NumPy and scikit-learn because linear regression or whatever. So I converted the skeleton of my project to Python, things like call stack statistics, financial tests, etc. So I was able to cover some ground with instrumentation in terms of like conceptually with Orbit. So I actually just need to go and rewrite that part in Python using Frida. But since I already have an idea of what I wanted to do with that, I already know the direction I'm going, and I started with the analytics now, just because analytics in Python way better than analytics in C++. Using Qt, nobody likes Qt. Even the people who made Qt don't like Qt, unfortunately. Well, maybe not, but it's a little iffy. So then I have things like obviously Flask, as I said earlier, for the analytics, for things like input forms to add like custom handlers for injection, etc. So hope I'm not too incoherent right now. I'll take questions, but I want to just keep moving forward because I don't want to take up too much time. So next we can see a couple of out of context screenshots, right? Because this is mainly a low level program, right? All of these other projects had some really beautiful UIs. Not necessarily me. I've got like 3 views, like that is it. So, there's like the Flask UI on the left here, you can go and add something to override parameters when it's called. Then on the right, we can, it's like a kind of a graph of the most frequent functions called in terms of just how many times it appeared. That's Pygol kind of working its magic, because God knows that I can't make anything look pretty. So I have to have a library to do that for me. So next slide, if that's cool. So arguably the best part of the presentation, I threw in James Franco on there. He's a handsome dude, so I'm kidding. My final remarks are, I got to finish up the instrumentation and the analytics with the remaining time in the semester. I might add a couple more types of market simulations, and then add a little bit more statistical analysis, because, taking the slope of a line just isn't really enough. You know what I'm saying, guys? So, that's pretty much it. I know that might have been very incoherent, but I am down to take questions if anybody has any. If not, all good. I wouldn't either.
Okay, it was good up until that last laugh, Matt. Good job.
Thank you. Any questions?
Let's why don't we? I'm going to pop out of here and let somebody else kind of jump back in. Let's see.
Thank you, Sai. I appreciate that, DM.
Who's our next competitor here, or our next group?
Competitor, Professor. I'm going to lose.
No, good job. Let's see. We have. I think this is our last one. Institutor. Is Institutor here? We are. Hannah's asking you what you plan to do with your great riches.
Oh, actually nothing. It's open source, so the riches are not going to me. Maybe somebody who uses it though.
Well, you can find a way to. There are ways to monetize open source. So don't get.
Can I do that for credit?
Oh yeah.
All right. Maybe I'll consider that then. Thank you, guys.
Yeah. All right. I think there's a couple other questions in there that maybe you wanna take a look at and answer online. But considering where we are, I would like to get started with in the chat where we are. I'd like to get started with Institutor so that we can finish up almost on time. So Institutor, are you ready to go? I'm not. I'm seeing your slides, but I'm not actually hearing.
We might ready for it. Thanks.
Yep. Okay.
Okay, I just want to tell the front end to jump in. Just wait us for a second, please.
Sure.
Can you hear me?
Yes. Loud and clear.
So hello everyone. Our project is Instant Tutor, and our team leader is Professor Musak. Our team members are Dorothy, Daxing, Jiangshu, Sai, Nicholas, and Yuqi. Next slide. Today we'll first talk about the introduction to the project, then the website setting, and finally we'll go over the future plan. Introduction. To give you a little bit of background, during the pandemic, we've noticed a high demand of tutors. So the idea of this project is to connect students that need help in any of the courses with tutors based on their skill sets. And we're trying to make a P2P platform that facilitates maximum resource utilization within the RPI campus. Next slide. Functionality. So first, students will submit a request or ask a question. Then the platform will do the matching and generate a list of tutors for students to pick. Once the students select a tutor, they will be able to interact with each other through chat or any other social media platforms. Next slide. This is the workflow of the project, and we've done with the register and selecting roles. We are trying to ask the students to search by typing in the course that they need help with and generate matching tutors. Next slide.
Hi, my name is Sai. This is my first semester on RCOS, as I think it is for many of our other members on Instant Tutor. So as far as organization, we have an MIT open source license for a GitHub repo. And below you can see a screenshot of our README. So it has a description for Instant Tutor. And it also has a link to a Google Drive, which includes our proposal as well as like design documents and other resources that we have. And we also have a description if anybody wants to run the app. As we are a first semester project, we don't have a ton of guides for how people can contribute, but we hope to add those guides as we progress more with the project. Next slide. So next we'll be talking about the actual website, which we created in the semester. So we use the MERN stack, and we basically have our team set up into the front end, back end, and a database team. But a lot of the members, it's very flexible, and we work on a lot of the different components. And at the end, we'll also do a demo. Next slide.
For the front end, what we currently have includes sign up and login for both students and tutors. They are also able to edit their profiles after they register. For tutors, they will be asked about their expertise, which are the classes that they're able to help. On the dashboard, there is a search bar for students to search for tutors, but we are still working on this feature. In terms of our team member, I'm the only one in the front-end team. I did the sign up and login part, and for the rest of the features, I also got help from other team members, and we collaborated with each other to do the profile page as well as the dashboard. Next slide.
Hi, so my name is Jiang Xuxing, and this is also my first semester in this course. And so I'm a member in backend team, and the main role for this team is to build the rules which work as bridge between the front page and database. So to achieve this goal, we use Node.js to to coding and use the platform called Postman, which can intimate the real user's requests, such as to get, push, and delete. And with this tools, we successfully debug in earlier stages and significantly increase the efficiency in later integration development. And for myself, I mainly worked on the user's profile, and also later on, I worked with Dorsey in front end with the profile form and expertise form. And next, Dashing will introduce more about this part.
Hi, my name is Dashing, and I was doing the RCOS first semester as well. I was one of the backend team. So as Zhang Xing mentioned before, we reference some online course to try to build the backend, and we use most of us using the Visual Studio to coding, and we try to do the API routers to set up to the link between the database and the front end. And that's basically what we do for the initial setting up. But since front end might lack of help, so we provide some help for doing the searching bar and doing the student profile setting. And that's the part that we basically focusing on. And next slide, please.
So for a database, RCOS Instant Tutor is a P2P program, which means we need to deal with problems such as high-speed logging and matching users in the real time. So for our team, our main concern is to deal with large volume of data with a high performance. And so we choose MongoDB as our database. Mongo is a document-oriented database which stores data in JSON-like documents with dynamic schema. And it means you can store your records without worrying about the data structure, such as the number of fields or type of fields to store values. And the Mongo documents are similar to JSON objects. The data are stored by field names and values. For our user profile, the field names include degree, role, major, education history, and social accounts. So now let's show our demo.
So I want to share screen. Is that okay?
Yeah, please.
Just going to share. Okay. So right now this is our website, and then you can sign up. So if we test, sorry, we setting a profile, and we can choose student, tutor, or both right now for the setting up. So if I choose tutor and the password just test, and you need to confirm it, and we can get into the personal page right now. And after everyone go to their personal page, they need to make a profile for them. So we can select like undergraduate, major is science. Right now I'm a tutor, and I can choose my expertise and the class I want to have, maybe calculus. Just location and briefly description. After we set up, it will say the profile is created. And if we click the search bar here, we need to do something later in the future, because right now I only have a search bar and our database did not collect enough data to make the search. So right now I just randomly pick a image search website to do the search right now. So right now it was having different kind of picture here. So if I type something, it will show some pictures that might relevant to it. And this is definitely where we need to focus on the future. And what we do is, if we want to edit our profile, for example, if I want to change my degree, if I upload it and it will update by itself, and I go back, I can just keep looking at my personal page. We will keep doing the experiments and the education in the future. So right now, I just make a warning page right here to make sure that we do not click by accident. After doing all the things, you can log out or you can delete it. If we delete it and the database just automatically delete all the history, and you will not have a duplicate user for the future that might cause some problem. And that's what we have right now. Thanks.
So my name is Nick. This is also my first semester in RCOS. And in addition to working on the database, I also focused a lot on getting funding for the group since MongoDB offers very limited free space. So we applied to the New Valence Fund, and we are also waiting for results from applications submitted to Amazon. And this covers the cost of the cloud storage in MongoDB. Next slide.
Yeah, so there's a link to our GitHub repo if you want to check out more of Institutor. Next slide. And as Daxon mentioned in our future plans, so hopefully the next part of our project is to implement the search bar so students can search for tutors based on what subjects they need help with. And we hope to start researching a matching algorithm so we can start to match tutors with students based on like reviews and the relevant areas of expertise. Next slide. Thank you. And does anyone have any questions?
All right, thank you very much. Any questions for the Institutor team? This must be a very difficult semester for the students because we've had a few tutoring projects, but it's really great to see that we have. I'm a firm believer in both Darwinism and in expanding to fill every available niche in the ecosystem. So it's kind of interesting to see that you guys are kind of serving the same general overlying theme, but going at it from different standpoints and different priorities. So good job. So the New Valence is you're using to pay for the server. Is that true?
Yeah, that's true.
And how onerous was that application? Was it something that was kind of hard and you put a lot of effort in, or was it kind of?
No, that one wasn't too difficult. It was we just added some more information to the project proposal. It was pretty easy overall. They still need to iron out some kinks in how they distribute money, and it was their first time doing it, so there's definitely a lot of hiccups. The application process was good though.
Nice. Have you thought about setting up a users group for advising yourselves as you move forward for beta testing or alpha testing?
I don't know if we've completely approached that point yet. I don't know. Does anyone else want to contribute or feel differently?
Yeah, definitely. We're still in the very early stages of this project, but hopefully once we have like the matching algorithm down, we can get a user group and start beta testing. That would definitely be in our future plans.
Cool. It's always good to get, to start thinking about that stuff before you need it, as opposed to after you already need it. Good job, guys.
Yes, definitely.
And thank you for waiting till the end of today. I think that was our last one. Am I correct?
Yes.
All right. So thank you, everybody. We will do this again in a couple of days with somebody else, I guess, with PollBuddy, Flom, Dorm Design, RPI Campus Map, Illyria, IAI Toolkit, Quacks, Clip, IARS, and RPI TV. So thank you, everyone. Thank you for all of you who hung out. Yeah, go ahead. All right. So we'll see you all later. Enjoy your night, and these will go up on our website.